Assalamu alaikum, my dear students. How are you? Hope you will be fine and okay. Our today lecture number 17, is about power, and this is the last topic we have. For this chapter, power. We discuss here a mechanical power, right? Last time I discussed efficiency with you in great detail, and if you remember the very beginning of this chapter, I told you that the chapter is based on work, energy, and power, and I told you that there are seems to be somewhat similar, but there is a great difference between all these quantities, physical quantities. So machine has a efficiency and machine has a power also, and both are 180-degree different from each other. For example, I just want to tell you that how they are differ from each other. I will give you a kind of example. You see, look at this bulb. As I told you, it has a different efficiency and it has a different power, right? They are completely different. For example, the efficiency tells you that how much this bulb is useful in converting maximum input electrical energy into a light energy when we switch it on like this, right? See, now, but what is power? What is the concept of the power? The concept of the power is different than the concept of the efficiency. Why? Because power tells us something different. Power tells you that how fast your bulb converts electrical energy into light energy. So that is the difference. Power is not associated, or power doesn't care how much of your input energy is used or wasted, but power take care of that how fast it does something for you. So that is the concept behind it. So, but physically, in physics, we define power as that it is what? That it is the rate of doing work. Power is what? Power is the rate of doing work. Clear? So this is sort of physical definition. It does not supply you any true concept. It does not give you any true concept. The true concept of the power is that how fast or how quick the given machine convert one form of energy into another form of energy. For example, how fast the bulb convert electrical energy into a light energy. How fast this trimmer convert electrical energy into a mechanical energy. Light energy is not always needed. So the greater the power, the greater will be what? The greater will be the greater the power, the faster will be the energy conversion. And let me explain it to you mathematically. We can say that power is what? Power is work done. It is the ratio of work done to the time taken. And if you remember, when I was explaining to you the efficiency, I told you that work done, it is what our output is. It is in fact the output energy which we are giving. So for example, if you have the trimmer, see, look, if you have this in your hand, then the power, what does it will? That how fast it provides you the mechanical energy from what? From the electrical energy. That how fast it converts electrical energy into the mechanical energy. So that is what? That is the power, right? So look, this power, it is denoted by P, and since it is based on the work done per unit time, right? So power is equal to what? It is the work done per unit time. Power is work done is measured in what? As we know that work done is usually measured in what? Work done is measured in joule, and time is measured in what? Time is measured in second. So joule per second is in fact the SI unit of power. That is what we call watt. So 1 watt, please, this represents a physical quantity, and this W represents what? It represents the what? It represents the unit of power, which is watt, and 1 watt is equal to joules per second, right? What does this means? That the power of the machine will be 1 watt if it converts 1 joule of energy in 1 second. What does this mean? For example, if you have a bulb which has power 1 watt, what does this mean? That the bulb has the ability to convert 1 joule of electrical energy into 1 joule of what? Make the light energy in 1 second. That is watt. So what is the SI unit of power? Second, power is a scalar quantity, right? Why? Because you know work is also scalar and time is also scalar, so the ratio between two scalar quantities. So power is scalar, it does not need any direction. And moreover, if you know the power, then you can calculate the amount of work done, P into T. So you see that, look, the smaller, the less the time taken, the greater will be the power. For example, one simple example I will give you about the, as I told you, for example, look, if this is a building, let us say, right, and this is the floor 1, this is the building floor F, that is floor 2, 1, yeah, story 1, story 2, and you want to go to story 3, like this one, right? So you see, you have 3 different paths. For example, you may arrive to the 3 by using what? By using the stairs. From the base, like this. So you see that if you want to move through the stairs like this. For example, you just go and moving through the stair. The stair is one path, right? If you want to move through the escalator, the moving stairs, for example, like as you see, these are the moving stairs. You might have seen in superstores everywhere like this, moving stairs. That is through belt, the moving stairs, right? We call it escalator, right? And one, you want to move through the left. The left will take you up, right? As you see, for example, here you want to use left, like this. This is a left. the same height you are taking in all the cases. Your height is the same as you see. Your sole purpose is from ground floor to third floor. So you take this height. In all the cases, what you see, your work done, the work done is the same. This is why, if you remember, I told you that a machine does not have the ability to increase or decrease your work done. For example, when you are moving through the stair, you are the machine yourself. You use yourself to move, right? You use the moving stair. The moving stair has its own mechanism. It is a kind of machine. You stand and the stairs take you up, right, through the third floor. You are moving in the left, right? You stand and the left elevator, right? That is called the elevator also. Escalator and elevator. And the elevator take you up. Clear? In all the case, the work done is the same. You have the same work done. But if I ask you a question, which will take you quicker to the floor third, you will all answer, sir, the elevator, the left. And this is our common experience, right? If you don't find the escalator everywhere, at least in every building here in the Taif, you have the elevator and you have this moving stair. So if you want to move to your house on the third floor, the elevator take you quickly, then you move yourself. So in all the cases, work done is the same. Going to what? What is the work done? Your work done is that MGH. The work done is the same, right? But who is doing it faster? The elevator, and then the escalator, and then you yourself. So who has a greater power? You, the moving stair, or the elevator? The answer is the elevator. Elevator has a greater power. Now let us see. Work done is the same. This is the same. Work done is the same in all the cases. So if work done is the same, which quantity makes the power greater? That is what? That is time. The elevator does the same work in less time than the moving stair and you yourself. So this makes the elevator with a greater power. Another example I would like to tell you. For example, if you have the electric drill machine, you have the drill machine, the one which makes holes in the wood or the wall. You have one, the electric drill machine, and you have one, the hand drill machine, the handmade drill machine. True drill machine you have in your hand. For example, look, if you choose a piece of wood, I'm sorry, I don't have, let me do this. See here, for example, this is the piece of the wood, the same thickness, right? And if you want to make a hole in it, you have the hand drill machine with which you just rotate. This is a mechanical based system. In it, there is they make holes in this wood which has the same thickness, right? And another one is the electric drill machine. You place and you press the button and it makes hole. Now it is our common observation. Which one will do it faster? Of course, the electric drill machine. So the electric drill machine has more power than what? Than the hand drill machine. The electric power supply are quickly faster convert the electrical energy into mechanical energy, while the hand drill do it slowly. So you have seen that again the machine only make the given work faster or slower, depends on its power, right? So the greater the power, the faster the work the machine will do. So that is all about what? That is all about the power of the machine. There are numerous situations. We can combine the mechanical power with the electrical power, right? And in various way, we can calculate the amount of energy required. For example, you can calculate the amount of energy possessing by water using the electric kettle by combining this equation with the thermodynamics or the heat equations. So that is very interesting. They combine electrical powers with the mechanical powers like that. So they help us a lot. For example, by using that, we can easily find out the time for boiling water in electrical kettle. Why? Because if you just see, look at the power of what, look at the power of the power expression. You see here, for example, as you have seen, what is power? The power is the ratio of work done into time, or as I told, that it is equal to P into T. So look, this is very important and very interesting. For example, you know that how much light energy you can get if you know the power of the electrical bulb. For example, look, if this the power of this bulb is let's say, for example, the power of this bulb is 40 watt. This is a 40 watt in bulb. So you see, look, the power of the bulb is 40 watt. So 40 watt means 40 joule per second. And if you lit up this bulb quite for 1 hour, means 3600 seconds. So you see how much energy, light energy, is being supplied to you by the bulb in 1 hour. So what it will be, 40 joule, and like this one, if you see, make this like 3 zeros, like this much joule, or I can say that it is round about 144 kilojoule of energy. So that is 144 kilojoule of electrical energy is converted into 144 joule of light energy in 1 hour by using your bulb. Let me check the calculation, is it? 3. Yes. So this is how we can calculate the power of this thing. This is not just we can do with this. There could be more from this formula. For example, this is just one of the standard form of this formula. Moreover, even we can express this formula, the power formula, in terms of force and velocity. For example, if you know the force exerted by your car engine, and if you can read the speed from the speedometer of your car, then you can also calculate the power of your the power of the your electrical the power of your car. For example, let us see. This is so easy. Let's see, what is power, class? Power is look, power is what? It is force into displacement, like this. And what I can write, class, may I write it this, if this is force, and you see that is distance by time, so they always give you velocity, F into V. So what is your power? Your power is F into V. So this is also very important expression, right? That power is the product of force and velocity also. So even if you know the power of your engine, and this is very interesting, if you want to know how much force your car engine create during your drive, right? Yeah, produce during your drive. Force, power into what? Velocity. So definitely there is written power on your engine, that the power of your car engine is this much, right? And if you know the speed, then you can calculate what? Then you can calculate the force produced by what? The force produced by your bike or your car. Even you can apply this to your cycle also, right? For example, look, this is not just along this expression which will work. There are many expressions. In many ways you can demonstrate this thing. For example, look, as I told you that what is the work done? You see, the work done is what? Work done, it is equal to P into T, right? And what is the work done? Force into displacement, P into T. So by rearranging this, you can even calculate your own power, right? So this is how we can apply the idea or the concept of the power to various machines. Second important point is that as I told, the power inversely proportional to time. Greater, that is smaller the time a machine takes to perform a particular work done, the greater it has the power, right? So that is all about what? It is all about the mechanical power. So in our today lecture, you have learned about power. Two things, that physically power is the rate of doing work done. You have learned one this thing. You have learned about the SI unit of power, that the SI unit of power is watt, which is written as joule per second. You have learned this thing also. The concept of the power you learn is that how fast or quickly the given machine converts energy from one form into another, from, for example, from electrical to light or from electrical to mechanical. So that is another one concept. Second, as I told you, the machine may have a greater power, but that the machine cannot increase or decrease the amount of the work done. Power has nothing to do with it. The second important point is that the power can be expressed in terms of force and velocity also, as I told. There is another unit of power also, I'm sorry I have forgotten, that is called the horsepower, the British unit of the power. And usually power are being sold in horsepower, are usually expressed for the water pumps, motors, big machine in horsepower rather than watt. And 1 horsepower is equal 746 watt, or 1 horsepower 746 watt, or 746 joules per second. If a machine does 746 joule of work done per unit time, then its power is said to be 1 horsepower. So that is all about the power. About its unit, physically it is a scalar quantity, right? Power does not have any direction. Okay, it is not important for the power to be direction associated. Okay, so that is our last topic of our this chapter, work, power and energy. And there is another important point. If you really want to calculate the power of the motor, for example, that is I just want to share this interesting thing with you. For example, if you want to buy the water pump for your building, which suits you the best. So what is the power formula? The power formula is work done per unit time, right? That is work done per unit time. And you know that if you want to take water, for example, water pump, this is, you want to move the water to a certain height, right? Like for example there, so you see that height h, you want to take it to a height h. For example, there is a water tank located on the top of your building, right? And if you want to pump the water from the base tank into the top for use, okay, so what could be the required power for the water pump which you will buy? So this is so easy. Now look, the work done will be equal to what? The amount of energy, potential energy possessed by the water at that very height. This will be your required work done. So definitely what I'll be writing? mgh and time. Now it all, that is the power of your water pump, all depends on the time taken. That in how much time taken you want the given mass of the water to be lifted to the top of the building. So it depends. that how much capacity your water tank has. For example, if you want to lift 10 kilogram of water, for example, you want to lift how much water? 10 kilogram of water, 10 kilogram of water to a height of 30 meter. The G value you already know, 10 meter per second square. Just in how much time? If you want to move this much of water in that is, let me make it easy, for example, in 10 seconds. So what could be the power of your motor? That will be definitely 300 watt, like this. And if you just calculate how much horsepower it will be, so that is 746 watt, and this is what, 300 watt. So this is just about 1 horsepower. So you will be needing half horsepower motor to carry the job for you, to raise the water to the top of the building, which is 35 meter high, and you want to raise 10 kilogram of water just in 10 seconds. So what will be this power of the right power for your water pump? So that will be nearly 1 horsepower, right? So that is all about our today lecture. Thank you very much for being here. Inshallah, in the next lecture I will give you the summary of this chapter, particularly the difference between work energy efficiency and power once again. So don't miss the next lecture. Thank you very much.